Okay, so this is the statistics of gallium arsenide, and electrons travel faster in gallium arsenide than silicon. This is also one property which makes gallium arsenide as a fast device, because electrons travel inside gallium arsenide faster compared to silicon. Or I can say the effective, when will electrons travel faster when the mobility is fast? When will mobility be large? When electrons are going to be light? So they say that the effective mass of electron is light inside gallium arsenide when compared to silicon. So this makes electrons move faster inside the gallium arsenide compared to silicon based semiconductors. Also, the gallium arsenide, by its inherent nature, it has a very good electron mobility characteristics. By inherently itself, this gallium arsenide is going to possess a high electron mobility characteristics. So already gallium arsenide is having high electron mobility, and the electrons are having a very less mass inside the gallium arsenide. So all these phenomena combinedly make gallium arsenide as a superior device in optical communication.